All right, so let's finish up these slides from last time, and then we have Java examples is the title of today's lecture. I kind of got a list of, I got to get Discord open. I kind of got a list of things that I want to cover as examples, but this is especially more so than any other lecture, since I'm not just running through slides, is where I'll take suggestions if there's something you want to see, something, especially if there's something you're having trouble with on the homework, and that's causing you issues, and you're like, man, I just don't know how to do this thing with an array list or whatever, then I want to talk about it. The few that I do have planned to talk about is what we mentioned last time, is creating and populating an array list in a single line, which is very, very handy for testing the average method. And the OR operator, I always forget to cover this thing in lecture because I just assume that everyone knows it, but coming from Python, you've never seen it before. So I want to cover that, which is handy when you're checking if a returned value is cat or dog, which is something you have to do in your testing. And I know we haven't talked about testing yet. We'll talk about testing next week, but those things will be very important when we get there. All right, so with that, let's clean up these slides first. Hash map. This is our typical key value store in Java, the one that we'll use in this course anyway. We had to pick one. This is the one we picked. It's not too much special compared to the other maps, but we're mapping one key to a value just like dictionary. I shouldn't say just like, but similar to dictionary in Python, or if you do know some JavaScript, it's like object in JavaScript. And I think it's map in C++ is the most common one, most common key value store. But this is what we're using to map keys to values. So instead of our array-like data structure, which is array list in Java, where we're storing values sequentially at indices starting from 0 up to the length -1. Instead, here we're mapping from specific keys to different values. And those keys and values can be any type. They don't have to be integers starting at 0. They can be any type we want, well, with some restrictions. Any type, I might as well just say what the restrictions are, any type that's not primitive. So the type has to start with a capital letter. Just like Java. Just like array list, this has to be imported. We can't just use hash map. If we don't have this import statement, once we start using our hash map here, we're going to get errors. Nothing's going to work. So we have to make sure we import this first. And I said this last time too, that we have to import it. Nothing's going to work. But realistically, when you're using IntelliJ, IntelliJ is pretty smart. It's a pretty sophisticated tool. Once you start typing in hash map, you start typing this line, IntelliJ is usually like, I know what you're doing. I'm going to add your import statement for you. Most times, not always. I don't know how it's hit or miss, but sometimes it doesn't. But a lot of times, it'll just add your import statement for you. Things are a lot easier these days. False. Things are not easier these days. Things are a lot easier, but that just means we ask you to do more stuff. So nothing actually got easier. You just get to accomplish more with the same amount of effort. Things aren't actually easier. Anyway, import your hash map. And then, because not to get on too much of a tangent, but the old, even before my time, like CS courses, you would take multiple courses, and by the end, you'd be able to like loop over a data structure, barely get anything done after years of studying. The stuff we can do now, we can get you doing after 1 year is pretty incredible. I think it's awesome. So hash map, it takes type parameters just like array lists, except we have two type parameters. The keys all have to be the same type, and the values all have to be the same type, but the keys and values don't have to be the same type. So we can have two different types. Here we have a hash map mapping strings to integers. So we have two types. String is the type of the keys, and integer is the type of the values. So we do have to specify both types, which is a benefit because we get to, we're not stuck with just mapping strings to strings or just integers to integers. We can map strings to integers, and that's perfectly fine. And just like array list, on the right-hand side of the assignment, this is optional. We can put string comma integer here, but it is optional. Java's going to look at the left-hand side and be like, I know what you mean, and figure that one out for you. When we want to add or retrieve information, put and get. I don't have too much to say, but we can't use the bracket syntax that we did in Python. Put, we have to have our methods here. Put is going to take a key and a value and put that key value pair into the key value store. And get is going to get you the value stored at a particular key. The types have to match. I don't really have anything else to say about that. That's the syntax. Put and get. And then what we do have to talk a little bit more about is how we're going to loop over this stuff. So we saw while loops and for loops last time, and we saw this for loop with the 3 different statements, and the while loop that was like a conditional that would loop until the condition is false. But here we have loops that are a bit more familiar to you from 115. These are more like the Python loops. Python only has for each loops. I call these for each loops because that's what they're called in a lot of different languages. Java does call them enhanced for loops. I don't know why, but Java calls them enhanced for loops. So if you ever hear somebody say enhanced for loop, if you just hear, oh, the regular type of loop, because this type of loop is way more popular these days, that this is just kind of like the standard loop. But I'll call them for each loops. And they're going to iterate over the values of a data structure, which is most of what we do with loops. Like we usually don't want the 3 statements. We just want to iterate over a data structure most of the time. Sometimes we'll have to go to our while loops and our standard for loops, but usually a for each loop is what we actually want. So this is our for each loop. And we read this as for value in data structure. And the colon is read as your in. In Python, you would actually type out in. Java, it's going to be a colon. Yep. You have to do key set. If you do, when we go to IntelliJ, we can try. I believe it's an error if you don't do that. If it's not an error, it would iterate over the entries, which are the keys and values simultaneously. But I think it just gives you an error. If you say for key in bills, it would break. With an array list, you can do for whatever in the array list, the variable itself. And that'll work. But for a hash map, it wants to know, are you iterating over the keys or the values? This is a variable. It's got to have a type. I assume we're all getting used to types at this point. It's a variable, needs a type. Every variable needs a type in Java. We can iterate over the key set or the values. I kind of mentioned it, so I might as well go all in on it. There is also entry set? But you can iterate over the entries as well, which iterates over the keys and values at the same time. For me, for my personal preference, I don't like to use that just because it's more syntax I have to remember. I don't like memorizing more than I have to these days. If you want to use the entries, that's fine. Go for it. Knock yourself out. But I'm not going to show it because I don't like it. So we can iterate over the key set or the values. Key set, it's going to iterate over only the keys. Values, it's going to iterate over only the values. What I like to do, my favorite way to do this, is iterate over the keys, and then the first line is to get the value. It's a little more verbose than the entry way of doing things, but I think it's more readable. I don't know. I just like it. Maybe I'm just scared of the entries. I don't know why. But this is what I like to do, because often you will need both the keys and the values, including on your homework. The third method is that best key method. You're going to need to iterate over the keys and the values. You need access to both simultaneously, and you're effectively running a max method, which you've seen extensively in 1.15, but running over a hash map in Java and needing the keys and the values. I'm taking a bunch of 1.15 stuff and making sure you can apply it to Java. So we will need the keys and values, so I recommend doing it this third way. Iterate over the keys and then access the values for each key. In action, our hash map, again in the tracing tool, you'll create this like any other object. Your keys are going to be effectively your variable names on the heap, and then the values are the values that are stored in those, bless you. In my slide, until I start using the tracing tool, will represent this as like a T-chart with the keys and values in the left and right of this thing. And then a reference. Reference is made up. I didn't mention this last time, actually. I think I forgot. But the reference is, for my slides, it's whatever 3-digit number I felt like, whatever came to my mind when I was making the slide. These are completely arbitrary, completely made up. The tracing tool, I believe, starts with 001, and then 002, 003, or 100, 200, I forget exactly. But the tracing tool will have some defaults for you. These can be whatever you want them to be. Whatever your favorite numbers are, just use them. I tend to stick with 3-digit numbers because when we get to the debugger, they're usually 3-digit numbers in the debugger in IntelliJ. So I kind of just stuck with that. But they can be whatever you want, as long as they're valid hex values, I suppose. So only the reference is stored in this variable, and that reference refers to a hash map on the heap, which can be anywhere in memory. In this case, at memory address 519. The reason I'm saying that, there's no meaning to the reference. You probably heard this in 115 a bunch, but for those of you who didn't take 115 last semester, the reference number doesn't mean anything as long as it's consistent. So if I have 819 on the stack or 519 on the stack and 520 on the heap, I'm wrong because that no longer refers to that hash map. But as long as whatever number I choose, I have it then the same in all the right places, then it doesn't matter which number I choose or which number you choose in your memory diagrams. And when we add our key value pairs, this is how we'll represent them. In our memory diagrams, it'll look like the name of the variable and then the value of the variable. But for the slides, I'll put my quotes around my strings because the keys are technically strings. We have some print statements. We're going to print things to the screen. And the one thing I want to, apparently not on this slide, the syntax for printing a hash map is braces, comma separating the values in pairs, and then equal sign between key and value, for what it's worth. I'm not big on the syntax of how it prints, but I want to say it. And next thing, this one I am big on. This one we have to not worry about, but not even think about. This is something we have to not be surprised about when we see our code doing this. The order of a hash map does not matter. Same was true in your Python dictionaries, though I think Python tends to maintain the order just by chance, kind of. But the order does not matter in a key value store in general in programming. The order doesn't matter in your key value stores. The order doesn't matter. So, which means when we're iterating over this, or in this case, when we're printing our values to the screen, right here, I just took whatever IntelliJ gave me, whatever was printed to the screen, and it happened to print out the key value pairs in the opposite order in which I added them to the hash map. And that's perfectly fine. Java's allowed to do that because it does not have to preserve any order. This is not a sequential data structure. With a sequential data structure, like an array list, if I added things in one order and got them in a different order when I asked for my values back, I'd be pretty mad. With a hash map, it's expected behavior. So when you don't get your key value pairs iterated over in the order in which you inserted them, it's perfectly fine, and you need to expect that and just be okay with that. You're not going to get any consistent ordering. I take that back. You will get consistent ordering if you use the same key value pairs every single time, or the same keys every time. You will get the same order every time. There is a method to the madness, but it won't necessarily be predictable. It won't be something you can easily predict if you've never added those keys into a hash map before. They will be, for those of you wondering, they're sorted on their hash value based on a hash function that Java's using. So it is deterministic, but kind of meaningless to us humans. Can we use an array list as a key or a value type in a hash map? Yes. Yep, you can. May or may not want to, but if your certain application calls for that, it is something you're allowed to do. Any type that you want. An array list of keys, your keys in your hash map being array lists, you can do it. The one caution I would give you is it's going to base your keys based on the references of those array lists. So if you have two array lists with identical values, that's not going to be considered a duplicate key unless they refer to the same object on the heap. So if you're relying on that no duplicate keys behavior, you're not really going to get it because it's going to be based on references. So that's the warning I'd give you. But actually, is that even true? I take that back. That might not be true. Because we don't have to talk about it. But ArrayList has an overridden equals method, and the hash map, I believe, is going to call that equals method. Maybe it would give you that behavior. I generally avoid such things, but it is allowed. Why I don't have the answer right off the top of my head. So in your memory diagrams, the reason I say this, in your memory diagrams, any order you choose is fine. Because you don't know what order they're actually going to be iterated over. When you're doing your memory diagram and there's key value stores and a hash map, you don't know which order they'll actually be iterated in. When you code this up and run it in IntelliJ, you just won't know that when you're doing your memory diagram quizzes. So you can choose any order. If you just choose the order in which they were inserted, that's perfectly fine. That would be probably the order we'd most expect to see. That's going to make grading mistakes less common if you just use that default ordering. I shouldn't say that, but because it's going to look like the solutions that the TAs are looking at if you just go in the normal order. But anyway, you can do any order you want, and you will earn credit for it. Oh, yeah. Which means when we're writing quizzes, which isn't me writing quizzes, this will be Paul. If Paul messes this up, we'll all yell at him. If there's ever a quiz that he writes where the order does matter, where like you would actually get a different answer, a different memory diagram if you iterated them in a different order, like say you're concatenating all of the keys in a hash map into one string, well, that string is going to be different depending on the order. So we shouldn't throw anything like that at you on a quiz, where the order would actually make a difference in your memory diagram, aside from the loop variables. So we shouldn't ever give that to you. If we do, we're yelling at Paul. All right, and then we'll go through our loop. Our first loop, we're going to iterate over the keys. So this variable key is going to iterate through the keys only. I feel like, yeah. And that's the question in chat. Perfect. Print and print line. So the difference between print and print line is print will not have a new line character at the end. So that's why the next line is printing on the same line. What is Alan's number? There's no new line character right here because we used print. And then the next one we use print line. So whatever's printed here, which is the value stored at Alan's key, is going to be printed on the same line, and then a new line character after. And then the next line is another print line. So this will have a new line character at the end. So print and then a new line character is print line, and then print, no new line character at the end. Good question. Yeah, and the previous question was the same thing. Same question. All right. No, this is correct here. It's just the difference between print and print line. All right. So if there are questions, please let me know. But I think we're pretty good on these loops. I can just show the example. We're going to iterate over the keys. The key goes from Alan to Diggs. And then that variable key is no longer in memory after the loop ends because that's part of the loop. Just like the iteration variable from the initialization statement in a regular for loop, a for each loop, this variable is part of the loop block. So it is removed from memory after that loop ends. And then when we iterate over the values, same idea. We're iterating over the values in whatever order we choose. If you just choose the order in which they're inserted, that'd be the common thing to do for the memory diagram. And then when we get to this third loop, we finally get to see an example of this in action. We have the variable key and the variable value, and we actually get to reuse these names because these variables are not in memory anymore. So for example, if we had key or value, if we had these variables declared outside of the loop and they were still on the stack, we can't reuse those variables. We can't have two variables with the same name in the same stack frame. It's not allowed. We can't do that in Java. In Java, we can't do that. It's not allowed. So when we get to this loop, if we're using these variable names, key and value, we can't have any other key and value, which luckily we don't, because this key and this value were in loops that were already removed from memory. We're done with those loops. We remove all of their variables from memory, so we are allowed to reuse those names, which in a case like this, where key and value are just the natural variable names to use here, it's the most descriptive code to have these nice, meaningful variable names. We do want to reuse these variable names in this case. So, or player and number. There's variable names that might make even more sense, but we would want to use the same variable name here as we do here, and the same variable name here as we do here, because they're representing the exact same information. So we get to reuse those because they were removed from memory. Program ends, everything's removed from memory, program's over. How would we show this in the tracing tool? I might just, no, I don't want to do a tracing tool example today. You would do this in the tracing tool you know what, I might have to, just to make sure it all makes sense. The one big difference is all of this would be in a main stack frame, and then this would look a little different. Maybe I should just show that. The reason I don't want to do the tracing tool yet, I'm waiting for a feature. I just requested it like Wednesday, I think, that they're working on. I want to be able to show the code and the memory diagram at the same time. You can do that on your quizzes, but I would have to create a new quiz for every single lecture. So I want an easy way to do that so I can use it in lectures. Yep. In the tracing tool, you mean? The next thing we're doing is live examples. Let's start in the tracing tool. If this goes horribly, you probably can't blame me for that. But let's try this. Oh, I added the link. You saw it just there, but I added this link to the course website. Trace practice. So we're going to create first thing we're going to do is create a new stack frame. This is the start of every memory diagram you're going to do in Java is a new stack frame for main. And then I got to remember the example we had, call it bills. We're going to create, I'm not going to write the IO. I think we got that part down from 115. But I'm going to create nope. Oh, no, I don't want that. There is no parent. The parent will be the constructor. We haven't talked about constructors yet. So this will be a hash map. I rolled 002, but just for the sake of example, I think I did 5 something. I'm going to do 517. For my reference number, Alan 17. What was? I want to make sure oops. Where did I put the slides? 519. Get it consistent. We'll do it right. We got this, and then our value for bills is going to be OX 519. And then to get to the question, we're going to create our loops. So we're going to create a code block inside this stack frame. Create variable in code block. Oh my. To be fair to me, the interface did change over the break, so there are little few things that I have to get used to. And this would be key, Alan, cross that out. Digs. And then we would cross out the stack frame. Can we not cross out stack frames yet? I think it was an issue. Is that still not a feature? Oh no. This guy? But that's going to cross out the whole stack frame, right? Is that still not a feature? Oh crap. Well, that feature is requested. We'll have to get Zeta on that one. Create code blocks. So we can create multiple code blocks, but we can't cross out each code block. And the code blocks aren't very distinct either. I got a few feature requests for them. But that's how you do it. You would create 3 separate code blocks and I guess not cross out any of those code blocks. This is how you would do your hash map, though, with the reference. Any questions on that stuff? Aside from crossing out stack code blocks, any other questions while we're in here? Yeah. I'm going to say no, just because we don't have a specific way to represent a hash map. There should be quotes around these. But since we're kind of in the tool treating them as variable names, if you had the quotes or not had the quotes, I'd be fine with that. Because technically they should, but this is being treated as a variable name, so technically quotes and a variable name would be illegal characters. So if we built something into the tool that enforced naming conventions, this wouldn't be allowed. So, I'd be fine either way. I'd say with quotes. With? Yeah. And then if this, while we're in here, if this were an array list, 0, and this, since it's values, this would definitely have quotes on it. Right. Variable 1. Oh no, can I uncross this out? So this is how we would do our array lists. Oh, and it incremented we do get a hex value there. It incremented my 519 to 51A, because this is hex. All right. Any other questions while we're in the tracing tool? Anybody want to see me stumble through another example? I'll be prepped with the tracing tool when I'm ready to actually do it as a lecture. Nope. So double quotes for strings in Java, double quotes only. So if you want a double quote as a value in your string, you have to escape it with a backslash. Not as versatile. The single quotes in Java is reserved for characters. So if you have a single character in a data type we didn't talk about, but char for a character, then you can put it in single quotes. So single quotes means this is a char. Okay, let's get out of here and get to something I'm more familiar with. IntelliJ. Oh, I didn't change my stuff. I just got to make this bigger. Okay, everything's bigger now. I forgot to do my cursor too. All right, And I have my trusty old cheat sheet. These are the things I want to do. So let's go through these things. We got plenty of time. Let's go through these things. We finished the slides. Done. Arrays.asList, the OR, and debugger if there's time. I don't know if there'll be time for the debugger. I could spend weeks on the debugger, but hopefully we get to do a little bit of it. So this is IntelliJ. When we get this set up, what I'm going to show is a demo of, at least the lights weren't off. That would have been much worse with the lights way down. And I'm going to grab the link for the example code. This is where all the code examples are that are in the slides. They're all in this repo. So I'm going to go to the repo, go to code, and grab this link right here. Well, actually, you might want to grab the HTTPS version. The HTTPS version takes less setup. I think this one works fine, too. If one doesn't work, use the other one. But I have my SSH keys set up, so I know it's going to work, but it might work anyway. And I'm going to click Get from Version Control, and I'm going to paste that URL. Simple as that. I have one more step to do. You'll just click Clone after that, but I have to add something to the end of this, because it's going to say directory already exists, because I already have this cloned. I already cloned the repo, and it's going to say you're trying to clone into a non-empty directory. So I'm just going to name this directory anything else so I can get it cloned and not interfere with my current version of this repo. And once I do that, what I have is a copy of all of the code, all those code examples, that entire repo. It's all downloaded onto my machine, and I can play around with all those examples. So I recommend all of you do this. If you didn't do it in lab last week, I think some of the TAs didn't go through all of, specifically this repo. They better have gone through some repo with you. But I don't know if they went specifically through this. So let's go through this one, and hopefully we'll run into a bunch of issues. What I want to do, what hopefully happens, is I run into a bunch of problems with cloning this and running the code, because then I get to show you how to debug a lot of the problems you may or may not come up with. But honestly, you all had lab last week. You should all have IntelliJ set up. So it probably wouldn't be the worst thing if we didn't have any problems. So I'm going to go to week 2. Let's go to that hash map example we just saw. Oh, come on, IntelliJ. I did this. Editor. Font. 24. Y'all watched me change that to 24. Okay. And to run this code, so we have this code example we just saw. It's just a main method. There's no other methods. And to run this, I have a lot of options. I can click this green arrow here, this green arrow here, or what I prefer to do is right-click on the file and click this green arrow here. They'll all do the same thing in this case, but there are some situations where you might click the wrong arrow when there's a whole bunch of them, a whole mess of them in the file. But right-clicking the file name and clicking Run is always going to give you what you want. There's also a green arrow up here. That one doesn't always do what you want, like for sure. That one will, so many office hour questions where I'm like, I told you not to hit that arrow too much. This arrow up here will run the last thing that you ran. So now that I ran this file, this button's going to do that same thing. It's going to run hash map example, and you can look at your history. You can run different things with the drop-down menu. But if I'm editing this file, this ArrayList example, and I hit this button, it's still going to run the hash map example code. So just be aware of that. That's going to run the last file that you ran, not the current file that you're viewing at the moment. That's tripped up a lot of students. They're running the wrong code, and then they always feel silly in office hours. Like I just say, you're running the wrong file. No, I'm not. Yeah, you are. Look, watch. Oh, damn it. But here I ran the code, and we see that we'll get it in the iteration in the opposite order as we did in the memory diagram. That's fine. It's a hash map. Order doesn't matter. But there's our code. Okay, so we didn't run into any issues. So I don't get to show any fixing of IntelliJ issues for better or worse. Probably for better because, like I said, you should all have it set up by now. So let's get into the next thing. Let's run this ArrayList example so I don't make the mistake I just talked about and accidentally run the wrong one. Here's our ArrayList example. We saw that. We did a memory diagram. We know what it's all about. What I want to show is how to create and populate an array list all in one single line. So let's just get rid of all this. You know what? Let's do one better. Let's create a whole new file. I'm going to create a new Java class. What I did was right-click on the package, went to New, and then Java class. I'll name it Lecture Example because I'm super creative. And we see that it created my package declaration and class name. IntelliJ is going to do a lot of stuff for us. It knew that I created this in package week 2, and I named it Lecture Example. It's going to do all that stuff for me. Then a main method, was it public main static args? I don't know. I do know it, public static main void. But I'm just going to type main and hit enter, and IntelliJ does that for me too. So all you have to do is remember main. You type main, and IntelliJ is going to get you covered. You don't have to remember public static void main. But you, over time, will just remember public static void main string args. And then my array list. Let's create an array list and auto import it. I don't have to think about my import. We want to know what these things are, but the tools do make things like that a bit simpler for us. I'm going to create an array list of integer. I'm going to call it numbers again because I'm super creative. New array list. And here's where we want to create an array list. I want to call like my average method on it. Here I'm just going to print out numbers because we're not going to do anything with this. But you're testing your average method on the homework, and you want to create an array list of a bunch of numbers. Let's make these doubles to make the analogy much, much more clear. Array list of doubles, exactly what you have to do on your average thing. Here's the magic. Arrays.asList 1.0, 1.5, 2.0, negative 79.333. So arrays.asList, you can see it auto-imported, but you do have to import the arrays class. This has a static method named asList, which is going to take any number of values and turn it into an array, and then the turn it into a list, and then the array list constructor can take a list as a parameter. So we're giving it a list as an argument, and then it's going to pre-populate its array list that it's creating with these values that we gave it in that list that we created from the asList method. AsList is going to, oh, come on, give it to me, is going to return a list of whatever values I gave it, whatever type I gave it. Then array list, oh, well, it takes a collection. I shouldn't have went into the Java code. It's a little too early in the semester to dive into Java code like that. Some of it's pretty cryptic. But this works, and now I have an array list. Despite what I just said, I'll use this arrow here just to show you a different arrow. I have an array list with those values in it. So arrays.asList saves you a lot of time as opposed to, numbers.add. Copy this a bunch of times, and then you'll do something like this. Instead of doing that, we don't mess with that. We're going to do arrays.asList. Cool. How would we show this in the, oh, that's an old question. Can you do arrays.asList numbers, assuming we don't know the parameter list being given? I can do you one better on that. Just jam an array list in there. I didn't use it. I think it's just because I didn't use it. Variable is never used. Thanks, IntelliJ. I know I didn't use it. I just typed it. You just jam an array list in an array list constructor, and that will give you a brand new array list with all the same values in it. Assuming that's what you meant. That's how I interpret your question, at least. If that's not right, let me know. All right, next thing. We have a situation where you're calling, call this actual, where you're calling a method, you're testing a method, and this method can either return cat or dog, and both return values are correct. If that doesn't make sense, you haven't read the homework, the task 1 document yet, which is actually fine. It's technically not assigned until Monday. But there's the third out of 3 methods to write is best keys, where you want to return the key mapping to the highest value in a hash map of strings to integers. And one of the examples I give is, what if I have a hash map that maps cat to 5, dog to 5, and like mouse to 2 or something like that. So there's a tie for the key that maps to the highest value. There's 2 different correct answers. A correct solution can return either cat or dog. When we get to testing, what we want to do is call the method and then figure out if the method did what it was supposed to do. Does it do the right thing? So if your code always returns cat and your test says make sure that it returns cat, that's fine and all until you submit to Autolab, and my correct solution in Autolab that I use to make sure your tests don't have anything broken, my solution returns dog, and your test says, well, you didn't return cat, so you're wrong. You have to accept either cat or dog in that situation. So if we have a situation, we're just going to pretend the actual is what came out of the method, and it gave us cat. We want something, and I'm going to use a Boolean. We'll set up actual testing and everything. We'll see how to do that next week. But we're going to set it up as a Boolean for right now. So if actual equals cat, else so this is effectively how our tests are going to look. We're going to say, hey, if we got the right answer, we're going to pass this test. If not, we're going to fail this test and say this code's broken. So if actual is cat, get rid of the clutter here. So if actual is cat, we're going to say, yep, that's cool. But then my correct solution says dog, which is a correct answer. It should be accepted by your tests, but your tests are going to say, that's not right. That's not how we do this. So how are we going to do this when we have one Boolean expression? Because one answer would be, well, if it's cat, then we're good. If it's dog, then we're good. But the problem is, once you say, if it's cat, we're good, it's not cat, so we're bad, and the test fails. So we want to do this in one statement, and in Python, you would say, or don't feel like typing too much. So in Python, we would do or, and we would do something like this, right? In Java, it's double pipe. This is our or operator in most languages other than Python. Python's the odd one out here. But it's the or operator. Double pipe is the character right below delete. I mean, I guess it depends on your keyboard, but shift and then that key, double pipe, if you've never used that key before. I don't know if I've ever used it aside from or operators. Yeah. If I want to do and, 2 ampersands. So now, when it's dog, we're right. When it's cat, we're right. So this is what we want to do when we're testing it. You have to have at least one test case that tests multiple correct solutions. And this is how we want to do it. We're going to use the or operator and check, is it this correct solution or this correct solution? Because either one is going to pass, and we need to use our Boolean logic to figure that one out. Multiple correct with or, boom. Any questions? Ready for a debugger today. It'd be awesome if we could get like 2 minutes of debugger, but I don't know. Yeah. Yes, but it's a bit more complex. With hash maps, at least for now, I recommend just doing dot put, dot put, dot put. There is, I don't even remember it off the top of my head, but it is a bit more complex. It's, let me try. Let me give it a shot. I think it's entries, map.of entries, and then I don't remember the syntax after that, but that's the method that we want. I don't remember the syntax off the top of my head. Yeah. Is wait, like this? What do you mean? Oh, that gave you an error? Oh no. Oh, I thought that would autoconvert. Oh man, that means I lied in lecture. Yeah, I thought that one would autoconvert. Java's usually good about autoconverting ints to doubles. That's a shame. If we do a 0.0 here, it'll work, for what it's worth. Yeah, you would know the best way we would do that. I would probably do double dot value of. So the best answer is just make sure your types line up, but I thought it would autoconvert those.